we have the matrix A equals 2, 3, negative 4. Well, you can read it. And we want to solve an equation AX equals B, where X is a 3-row column vector and B is a 3-row column vector. Now, in order to do that, we could use X equals A inverse times B, because if we multiply both sides by A inverse, as we've seen many times, we do get X equals A inverse B. We could do that if we could find A inverse. Now, how do we find A inverse? Well, I'm going to show you. It's going to take a little while, but it'll be good practice with row reduction, matrix reduction, okay? To find A inverse, what we do is we reduce this matrix. Now, what's this matrix? Well, here's the A matrix, here's a dotted line, and here's the 3 by 3 identity matrix. We're not going to prove this. That's a good subject for linear algebra course. So we're not going to prove that it works, but it does, and take my word for it. It can be proved. It's not that hard to prove that if you reduce this left side to the identity matrix by adding multiples of rows to other rows and so forth, in other words, using the kind of valid operations that we've used in row reduction, those operations that mimic what we do when we add multiples of equations to other equations, and rearrange systems of equations in that manner. If we do that, if we reduce this using those operations to the identity, then what we're going to get over here is going to be the inverse. So we say that we reduce this matrix to this form with the identity over here, and I'm just putting asterisks to stand for numbers over here. We don't know what the numbers are going to be, but it'll be this form. We'll have 3 rows of 3 numbers. And this matrix we're going to call A inverse. So let's begin. Here's the matrix we want to reduce. Now our goal is to get the identity over on this side. So what do we do first? Well, I recommend first that, as before, we're going to want to get zeros down here. As a preliminary to getting the zeros here, let's get a 1 here, because that's going to make our arithmetic a little bit simpler. And we ultimately want a 1 here anyhow, so let's go ahead and get it. So we're going to take the first row here. How do we get a 1? Well, if we multiply through the whole row by 1/2, that's a valid operation. Multiplying an equation by 1/2 doesn't change its solutions. So we can multiply a row by 1/2, and we get this row. Multiply every number in this row by 1/2, and this is what we get. And then we leave everything else the same. Okay, no change in these 2 rows at this point. Now I've circled a couple of numbers, and we'll see what I was up to in doing that. Now, what do we want to do? We want to get zeros here and here. To get a 0 here, it looks like we're going to subtract 5 times this number from this number. So we're going to do the second minus 5 times the first, and we'll get a 0 here. And then, for similar reasons, we'll do the third row minus 2 times the first, and we'll get our 0 here. Now, of course, we don't get those zeros for free. We've got to do the whole row. So let's do it. Second times 5 times the first. Okay, that's 5 minus 5 times the 1, which is 5 minus 5, which is 0. Then 7 minus 5 times the 3/2. Well, that's a fraction, and we have to do a little bit of arithmetic to do that. But 7 minus 15/2. 5 times 3/2 is 15/2. 21/2 minus 15/2 is, I'm sorry, multiplied wrong. 14/2 minus 15/2 is negative 1/2. In any case, if we do this minus 5 times this, we get the negative 1/2. What I said there, second time, was correct. Then if we do 6 minus 5 times the negative 2, minus 5 times negative 2 is plus 10. Added to 6, we get 16. We do the second row, which has a 0, minus 5 times the first, so that's going to give us minus 5/2. And then second minus 5 times the first. Well, the first just has zeros here, so the second row is not going to change down here. Then the third. Okay, we got to do third minus twice the second. 2 minus 2 times 1 gives us 0. Negative 1 minus 2 times 3 halves will give us negative 4. Negative 3 minus 2 times negative 2 gives us 1. Now, the blue circles indicate that this comes from this and this. This minus 2 times this. This is this minus 2 times this. And we actually do that calculation over here. Okay, so we see that we want to do negative 1 minus 2 times 3 halves. So negative 1 minus 2 times 3 halves gives us what? Negative 1. 2 times 3 halves is just 3. So it'll be negative 1 minus 3 or negative 4. The numbers in the boxes here, we want to do negative 3 minus 2 times negative 2. That's negative 3 minus 2 times negative 2, and that gives us 1. Minus 2 times 2 is 4, so that's a plus 4, and a negative 3 gives us a 1. Then we do the third row minus 2 times the first. Minus 2 times a half is negative 1. Third row minus the 2 times the first here is 0. 1 minus 2 times 0 gives us the 1. So that at this stage we've taken the original matrix and we've at least gotten our zeros here. Now we've got a ways to go. We've got to get a 0 here. Then we've got to get zeros here and here. So that's going to take just a little bit more work. But we're off to a start here.